So here for session 2 of our deeper look at arrays, what we're going to do is look at really two of the most important subsets of array operations that we have. These are going to be the search and the sort. Now, we've already looked at an array in very much the same way we would have looked at file operations, right? We have things like we can use do or repeat until or do while loops so that we can iterate through the different elements of an array. We have read data in either via the terminal from a user, or we have read data in from a file actually into an array. We have outputted material from an array to a display or to a print. And next, what we really have to worry about are two of the biggest reasons we rely on arrays in the first place, and that is searching an array and sorting through an array. So before we go through and do this, we're actually going to do it in separate parts. There's going to be 3 more parts to this, the search part, the sort part, and then the challenge aspect afterwards. Before we get to that, it's probably worthwhile just to stop one more time and picture what essentially happens with data in an array. So again, we can think of an Excel spreadsheet as a multi-dimensional array, right? At the very least, we can think of it as a 2-dimensional array. We would have, along the top, we would have our labels, and then going down our columns, we would have whatever individual data points we would need to represent. So again, we could have individual salespeople with individual sales goals by month, right? So each row would correspond to a salesperson. Each column down would correspond to whatever their sales were, right? And if we just look at that, it doesn't really convey to you the next user in the chain. It doesn't really convey to you a lot of meaning, right? It is just data points, and they are just on display. Now, that's better than nothing. It's better than a guess, but it still relies on you to have to go through and actually, be involved with the math of everything, right? Okay, now I have to find which is the highest number. Now I have to find which salesperson that corresponds to. Now I have to go and see how much higher that sales figure is when compared to any of my other salespeople. And it's true, sure. If you have 3 or 4 or 5 salespeople, that investment of time isn't tremendous, but still, that leaves a lot of margin for error. And that's not why we have data sciences, right? We don't have Excel spreadsheets to increase the margin of error. We have them to reduce the margin of error. We have them to reduce the amount of time it takes to actually sort through and get the kinds of data it is that leads to the information that helps us make decisions on the other side. And all of those things put together are why we rely on arrays. Remember again that an array is very much the same as a file. It is a collection of homogenized records. So that means they are of the same data type. It means that they relate to the same core concept. So salespeople, attendance records, balances on a balance sheet, whatever that might be, they all relate to one another. Additionally, they are all of the same size. That is something to note when you get to your compile and runtime languages, that each one of the records, or the elements rather, in an array is going to have the same size. That helps you kind of key in on some of the structurally important elements of the actual, array itself. In an array, it is what is known as contiguous storage. So when you set aside a 30 integer array, what happens is in your compile and your runtime environment, the system, so whatever system it's running in, will actually go through and locate a contiguous storage space. So one long continuous storage that has enough space for 30 integer values. If you declare a 30 string array, the runtime environment will have to go through and find a contiguous storage space for 30 strings, which is entirely larger than the 30 integer array storage space would be. So now that we have a little bit of an idea as to what we're using the arrays for, now that we have a little bit of an idea about why it is that it's good that we have, the ability to sort and to search through them, let's take a look at a really keen physical analog, something that you can touch, something you probably haven't thought about in a long time, unless it's holding up, the back end of a pool table someplace in your basement, and that is a dictionary. A dictionary really does represent essentially a batch of array operations. Now, this tremendously old dictionary, frankly, has tens of thousands of entries in it, right? And each one of those entries we can think of as essentially two different arrays. We would have one array that has all of our dictionary words in it. So as we start with aardvark and we work our way all the way to xylophone and everything in between, each one of those dictionary words represents one element in the dictionary word array. Each one of them has a corresponding definition. That definition would not be in the word array, it would be in a separate parallel array, and that would be dictionary definitions array, or something to that effect. Now, the challenge part here is as follows. I think that all of us, I'm going to go out on a limb for you all here, I know that all of us have searched for a dictionary word at some point in time in our academic or personal just careers, right? We have gone like, well, I have no idea what erudite means, and we have to go to a dictionary to find it. Now, I know we would simply go to Google to find that out, but at some point in time, we did not have phones in our pockets. Most of us did not have phones in our pockets, and we would have had to look that up. Before we get to any of the more complex issues here, I am going to essentially install into your week a couple of artificial breakpoints that I ordinarily would not want to do, but I really want to hammer home some of the discovery aspects here for searching first and sorting second. So what we are going to do is break this down, like I mentioned before, into three discrete parts. The first part is going to be the search, the second part is going to be the sort, and the third part is going to be the challenge set. So the first part, and that is next, is what do you do for a dictionary sort?